Okay, so I'm gonna go backwards a bit, and maybe I should have done this first, but it's okay. So, one of the topics you put is just linear algebra. Now, I don't know about Denmark, but here in America, we take a year just to go over everything in linear algebra, or like 9 months, not a year, I guess. So I don't know what it means, the fact that you just put linear algebra. So instead of going through like nitty-gritty details, I'm just gonna put the like the intro topics you would see, and much of this like you would already know and go through. So linear algebra, it basically is just like the math of vectors, matrices, and system of equations. So the main idea is that linear algebra studies things that can be added together and scaled. So examples is that they combine directions in vectors, they solve many equations at once, like in systems, and they transform spaces, which is like the matrices component. So first things first, we're going to define a vector. So what is a vector? So a vector is an object that has it has magnitude, which is its size. And the second component is that it has a direction. So a vector is usually written as like this form. A and B. I did not mean to write a 9 there. So A, B. So an example is like 3, 4. So this means that in this vector, it moves 3 units horizontally and 4 units vertically is what the vector means. So it would have like an arrow pointing there after moving 3 units horizontally and 4 units vertically. So the second thing I want to go through in linear algebra is vector addition. So you can add vectors by adding the matching components. So say, for example, we have vector u, 1, 2, and then say we have vector v, which equals to 3, 4. Then it could be vector u plus vector v equals, and matching the components, 1 plus 3 and 2 plus 4. So the answer would be 4, 6. So this is just like the same as like matrix addition that we have already went through. Now let's go over scalar multiplication. So a scalar, as we know, is just a number. So for example, we can have 3 times 2, 5. So what we do is we have to multiply every entry, as we've already know. 3 times 2 and 3 times 5. And then our answer for this would be 6, 15. So this means that the vector becomes 3 times longer. Now, the fourth thing I want to go over is called a linear combination. So a linear combination means a times vector u plus b times vector v. It's going to be in this form, where a and b are like numbers and coefficients. So for example, an example would be 2 times 1, 3, plus 3 times 2, 1. So the first step is to multiply, right? So this would be 2, 6, plus 6, 3. And then our second step would be to add the matching components. So then it would be 8, 9. The fifth thing I want to go over is matrices, as we have already looked at previously. So a matrix is just a rectangular table of numbers. So for example, 1, 2, 3, 4. This is a matrix. So this matrix has 2 rows, 1, 2, and 2 columns, 1, 2. So we call this a 2 by 2 matrix, as we have already established and looked at a lot. Now, the sixth thing I want to go over is matrix addition. So You can only add matrices with the same size, remember that. If they're different sizes, we cannot add them. So an example would be 1, 2, 3, 4 plus 5, 6, 7, 8 that we've previously looked at. So we add all the missing positions. So this would be 1 plus 5, 2 plus 6, 3 plus 7, 4 plus 8, which would then become 6, 8, 10, and 12. So that is matrix addition. The seventh thing I want to go over that we have spent a lot of time on previously is matrix multiplication, and this is one of the most important topics. So the rule is row times column, right? Row times column. So an example would be we have matrix A, 1, 2, 3, 4, and we have matrix B equal to 5, 6, 7, 8. So we want to find AB, right, by multiplying. So first we will do the top left. And we're gonna have like our new matrix, that's our final answer, will be top left, top right, bottom left, bottom right, because matching like the respective positions of the matrix. So for top left, it's gonna be first row, first column, and then multiplying and like the respective numbers. So top left will be 1 times 5 plus 2 times 7. So we multiply the first numbers, add it to the second numbers. Now we move on to doing top right. So we use the first row again, except we use the second column, and multiplying and adding the respective numbers. So 1 times 6 plus 2 times 8. And this is going to be equal to 5 plus 14, which equals 19. And this is going to be equal to 6 plus 16, which equals 22. Now we can move on to the bottom left. And remember, the order we do this in is in top left, top right, bottom left, bottom right. So now we can move on to bottom left. Now we can move on to the second. So when we look at the bottom, we move on to the second row. And then we use the first column again, and we do 3 times 5 plus 4 times 7, which is 15 plus 28, which equals 43. And then now we do the last component, the bottom right. And we look at the bottom row, except we use the second column now. So we do 3 times 6 plus 4 times 8. So this becomes 18 plus 32, which becomes 50. So our AB new matrix will be 19, 22, 43, 50 in its respective positions. So that is matrix multiplication, as we have already went over. Now the eighth thing I want to go over is the system of linear equations. So a system is just multiple equations solved together. So for an example, we have x plus y equals 5 and x minus y equals 1. Our goal is to find x and y. So we can do this with the method of elimination, because when you notice that when we add the equations, the y's cancel, because y minus y is 0 and it cancels out. So we can do that with the method of elimination. So when we add the two equations, we have x plus y plus x minus y equals 5 plus 1 after adding them. So you can see that the y's will cancel out because y minus y is 0. We have x plus x, which is 2x, and then our right-hand side is 6. Now x equals 3. Now because x equals 3, we can substitute it back into our first equation, or second, up to you. So we have 3 plus y equals 5. Now y equals 2. So our answer is we have x equals 3 and y equals 2 as our answer. The ninth thing that I want to go over is called the matrix form of a system. So say we have this system. We have 2x plus y equals 5 and x plus 3y equals 6. This can become a times vector x equals b, where a equals 2, 1, 1, 3. Remember that we just take the coefficients out and plug it into a matrix. X is the same thing always. We have our two components, our two variables, x, y, and b will be our solution set. Our solution on like the right-hand side, which will be 5 and 6. So this is how we can rewrite this whole system as just like a form of matrices, right? The 10th thing I want to go over now is called the identity matrix. So this identity matrix acts like the number 1. So for a 2 by 2 matrix, we have the identity matrix that equals 1, 0, 0, 1. Because AI equals A. As in anything times 1 will be that anything. So that is how the identity works. The 11th thing I want to go over is the matrix inverse. As we know, the inverse is like division. So for numbers, for example, we have 5 times 1 over 5 equals 1. For matrices, we have A times A inverse equals I. And remember that only some matrices have inverses, and I went over that in the inverse video. Now we have the 12th thing I want to go over, and the final thing in our crash course I want to go over is the determinant. So the determinant tells us if a matrix can be inverted. So let's just say for matrix A, give it random values A, B, C, D. The determinant of A equals AD minus BC. So if the determinant of A does not equal 0, the matrix has an inverse. If the determinant of A equals 0, there's no inverse exists. And this is really important to remember because you always have to check first if a matrix has an inverse before taking an inverse, right? Now I want to go over a couple of problems you may see on an exam. So first, exam problem 1 is we want to solve this system. 2x plus y equals 7 and x minus y equals 2. Step 1 is that we want to add the equations because you'll notice when we add the equations, the y's can cancel out. So we have 2x plus y plus x minus y equals 7 plus 2. So when the y's cancel out, we're left with 2x plus x, which is 3x, and we're left with 7 plus 2, which is 9. Now our x will equal 3. Now we can substitute it to solve for y. So we're going to use this equation and plug it in because it looks a bit simpler than this to plug it in, right? So we're going to have 3 minus y equals 2, which means that negative y equals negative 1. And when the negatives cancel out, we have y equals 1. So our solution to this system is x equals 3 and y equals 1. So this is very basic algebra, but it is technically considered linear algebra again because these are linear equations. Exam problem number 2, I want to work on multiplying matrices. So let's just say we have matrix A, 2, 1, 0, 3, and matrix B equal to 4, 5, 6, 7. And then we have to find AB. So we have to multiply, right? Again, start top left. That's where we always start, the top left value. So we're going to do first row, first column. 2 times 4 plus 1 times 6. So it's going to be 8 plus 6, which equals 14. Now top left is done, we move to top right. Top right. So because we're still dealing with our top, we're going to still take the first row and then the second column. So 2 times 5 plus 1 times 7. Then this will be 10 plus 7, which will equal 17. Now we can go to our bottom. So now we work with bottom left, and we do left to right first. So bottom now, and then first column, so 0 times 4 plus 3 times 6, which will be 0 plus 18, which will equal 18. Now we can move to bottom right now that we've done our left. And again, we're still looking at the second column and the second, no, we're looking at the second row and the second column. So we have 0 times 5 plus 3 times 7, which will equal 0 plus 21, which will equal 21. Now we have, first we do our top left, which is 14. And this is our new matrix AB. Top right, 17. Bottom left, 18. Bottom right, 21. So this is our new matrix AB. Now we're going to move on to a more exam problem. Exam problem 3. We want to find the determinant of this matrix. 3, 2, 5, 4. So the formula, remember, the formula for determinant is AD minus BC. Remember this very carefully. So identify that 3 is A, B is 2, C is 5, and D is 4, right? A, B, C, D. Simple. Now we plug it in. So determinant of A is going to be diagonal 3 times 4 minus the other diagonal, minus 2 times 5, which will be 12 minus 10, which will be 2. So the determinant of this matrix is 2. And since 2 does not equal 0, this means that the matrix has an inverse. So if you wanted to find the inverse of this matrix, that's possible. So now we went over the 4 main basic things of the topic called linear algebra. We went over vectors, matrices, systems, and determinants. And I want you to think of this whole course summed up in one sentence. It's basically linear algebra. It's basically just solving and understanding AX equals B. This is all of linear algebra basically summed up in one equation. And that's it. So this includes everything from vectors, matrices, determinants, transformations, connected back to this one idea we got going on over here. And that's it. That is linear algebra, and that is a crash course introduction to my fifth favorite thing in math. So like and subscribe, okay? Really. Yeah. I'm gonna go get a strawberry. I don't know.